Hey everybody, probably the last time I will see you before spring break, but I definitely want to go over your review paper for your test, so that way if you guys have any questions you can let me know. Obviously I have office hours today, so if you guys want to pop by at 10:45 and ask questions, we can do that too. Tomorrow we'll do just some extra review stuff. I'll give you guys some practice. And then Friday I'll send you your test. So let's see, the first one here, it says that g of x equals ax to the second power. And they want it to open down and be narrow. So remember, to make it open down, we need a to be a negative number. So it's got to be either a or b there. And then if we want it to be narrow, we want a number larger than 1. So in that case, it's going to have to be option A, -3. Number 2, average rate of change. Remember, if you want to find average rate of change, what you're going to do is you're going to plug in -2 into this function. Like so. And then we also want to plug in f of +2 on the other end of the interval they gave us. And then when we get those numbers back out, we're going to have points to find slope with. So -2 squared is 4, times 2 is 8. 8 plus -2 is 6, plus 5 is 11. So we have the point -2, 11. 2 squared is 4, times 2 is 8, plus 2 is 10, plus 5 is 15. And then we also have the point 2, 15. And then once I have my 2 points, so whatever I got out is my y's, whatever I plugged in is my x's, now I can just find the slope. y2 minus y1 over x2 minus x1. It's going to give me 4 over 4, which equals 1. So the average rate of change there is 1. Number 3, which statements are true? Well, about g of x and f of x, g is going to be wider than f because it has an a coefficient that is less than 1. F and g do have the same vertex. Remember, they don't have a b term, so that means our vertex is going to be 0, for the x at least. They also don't have a c term, which means no vertical shift, so then it's going to be 0, 0 for both of them. And if they have the same vertex, that means they have to have the same axis of symmetry, because that's going to tell me where that vertex is. Let's see, number 4, where is it increasing? Some people in class had questions about this one. So remember, increasing is going to refer to the y values. When are the y's going up? So, on my table here, the first number there is -8, and then it goes to -2, and then it goes to 0. Those are increasing. Those are going up. But then it starts to decrease. So the interval, remember what this parabola is going to look like. It's going to go like this. The interval where it's increasing is going to be -infinity to 0. So it's the x values of where the y values are increasing, going up. So -infinity to 0, final answer. Number 5, we're just looking at the shifts. So remember, inside here, let's see, f of x. This number is going to tell me my horizontal shift. So in this case, it goes right 2. So my vertex is going to be at 2. This one goes up 3. So my vertex is going to be at 3. So I don't even have to do anything. I could write it out in standard form, but I actually don't need to do that. So I can just do it right from the shifts. Number 6, what's the axis of symmetry? Again, I can kind of just use my shifts. I know if the base function has a vertex at 0, 0, which it does, then I know this one's going to be shifted to the right 3. It's going to be flipped, so it opens down. and it's going to be shifted up 5. But our axis of symmetry, I only have to look at the horizontal shift. So this is going to be x equals positive 3, because it's going to move to the right 3. And number 7, they start you with this point, or this function. So I know that my vertex in this one is to the left 2 and up 2. And then it says that they want you to shift it to the right 5. So my new vertex would be at 3, 2. So then which one gives you that equation that would have a vertex at 3, 2? It would have to be A, because it gets shifted to the right 3 and up 2. That's the only one that gets shifted that way. Number 8. All right, so now we get to some meat and potatoes here. Number 8, they give it to you in vertex form, and they want to know the vertex, which is easy, and the y-intercept, which is not so easy. So for vertex form, that's easy. This shifted to the left 2, down 3, so it's at -2, -3. Now the y-intercept is a lot easier in standard form, so we're going to turn this into standard form. So x plus 2 times x plus 2 minus 3. X times x is x squared. 2x, 2x, and 2 times 2 is 4. And then just add your like terms. 2x and 2x is 4x. And 4 and -3, all right, is just going to give you 1. So the c term is going to tell me my y-intercept. In this case, it is just 1. So my y-intercept is 1. Very cool. Number 9, it goes 4 units right and down 1 unit from x squared. So we're just going to write it in vertex form, like as if it was shifted. So h of x, h of x equals, we want it to go right 4, so x minus 4. Remember, always opposite sign inside. Squared. And then down 1, so we need a down 1 on the outside. Number 10, the axis of symmetry. This is where they gave it to us in standard form. So we're going to use our -b over 2a. And that's going to be, let's see, our b term is 8. So we're going to go -8 over 2. The a term is 2. -8 over 4 is just -2. So the axis of symmetry is x equals -2. All right, rock and roll there. On the back side, number 11, we have a vertical motion model. I noticed they didn't make you write one out, but on your test, that might be a thing that we do, because we talked about how to do that. So all we really needed was the vertex here in number 11, because I want to know the max. So let's see here. H of t. So my b term is 24, so -b over 2a is going to give me -24 over -32, which is just 3/4. So then you just plug 3/4 in for t. Like so. And it looks ugly, but it's actually really nice. 3/4 squared. 3 times 3 is 9. 4 times 4 is 16. And when I multiply that by -16, these will cancel out. We just have -9. 24 and 4, I can simplify that. That's 8. Wait, that's 6. That's what I meant. 6 times 3 is 18. And negative 9 plus 18 is positive 9. So h of 3/4 at 3/4 seconds, it's going to be 9 feet in the air. That's the maximum height. Pretty cool. Number 12, I had some questions on 12. So they gave you f of x equals negative x squared plus bx plus 1. And they want to know the what the b value could be for this function that they, or the graph that they gave you. Well, the only thing we really care about on this graph is the vertex. And it looks like it's at the x value of 2. Be careful. They made the graph go by 2s. They didn't label it though. So be careful. They didn't label each mark at least. So we want an x value of 2. So somehow I want this to be negative b over 2a equals 2. Well, let's see. Negative b, negative 2 times 1. I'm sorry, 2 times negative 1 is negative 2. Times by negative 2 on both sides. You get negative b equals negative 4. And divided by the negative 1. And b is going to have to be 4. So the b value up here, if it was 4, then we would have the axis of symmetry that we would like. 13. Yeah, let me draw that one out for you. So we have a painting that's 5 by 11. And then a frame that's W. That's W inches wide. Sorry about that. So this is W all around. This 5 I'm going to put inside so it doesn't get confusing. And then we want to know if quadratic equation for the area of the whole thing. You guys see that? That is not very good, is it? I thought the black might be helpful. Okay. This is W. This is W. 5 inches. 11 inches. That looks a little bit better. All right, cool. So to write this side from here to here, it's going to be 5 and a W and a W. So it's going to be 2W plus 5. And then this side, from there to there, is going to be 11 and a W and a W. So that's going to be 2W plus 11. And so really what we want to do after we model it like that is just to go ahead and multiply it through, because we want the quadratic equation. So 2W times 2W is 4W squared. 2W times 11 is 22W. 5 times 2W is 10W. And 5 times 11 is 55. And then add your like terms, and our final function, f of x, is going to be 4W squared plus 32W plus 55. Very cool. And then they want you to figure out the domain and the range if that W is anywhere between 1 and 3. Sorry about that. After I sneeze, I gotta blow my nose, you know, it's the thing. So, first of all, the number they want you to plug in, that's always like our x. So our domain is gonna be 1 to 3. Because that's what we gotta plug in. Our range is gonna be whatever we get when we actually plug those in. So when I plug in 1 here, 1 squared is 1, times 4 is 4. 1 times 32 is 32, plus 55. 87, 91. So the lowest number of inches for this is the area. If it's 1 on this W, we're going to have 91 square inches. And if we plug in 3, 3 squared is 9. 9 times 4 is 36. 3 times 32 is 96. Plus 55. And that's going to give me 187 square inches. So our domain, if we plug in 1 to 3 on W, we can get a range anywhere from 91 square inches to 187 square inches. And I just plugged in our numbers into the function. Number 15, the rate of change is the same from -2 to 1 as it is from 1 to 4. That's linear. It has to be linear. I did not put one like that on your test, but I did put one like 20 where you had to actually use the table, find the differences, and see if it was linear, quadratic, or exponential. Number 16, you're going to use Desmos for that in your on your test, hopefully, and get the line of best fit. C is the one that best fit it, and it should have hopefully used a quadratic regression. It's quadratic. Number 17, you just had to fill in the residuals. So remember, I'm not sure if I talked to you guys about residuals even. That's weird. But the residuals are just, you subtract the actual amount minus the predicted amount, and then you write what you have down. So for example, for x is 0, I got a residual of 1, positive 1. When x is 1, I got a residual of -1. When x is 2, I got a residual of 0. When x is 3, I got a residual of -1. And when x is 4, I got a residual of -2. The closer those residual numbers are to 0, the better your correlation coefficient's going to be. The better the parabola is going to fit. So you want those residual numbers to be lower. The lower they are, the better the function. So here in 18 it says, which function is better? F is better. Because G, the average is 1.3. If you take the average in F, it's going to be less than 1. It's going to be much closer to 0. So, yeah. Number 19. What interval does 3 to the x power increase faster than 9 to the x power? Or 9x. Okay, that's kind of weird. Well, we know exponential functions are going to increase much more quickly than most of our functions. This should have been on our last test, I feel like, but that's fine. So if you want to know where they increase faster, plug in the choices, right? From 0 to 3, this goes from the number 1. When I plug in 0, when I plug in 3, 3 to the third is 27. So that goes up 26. When I plug in 0 here, it's, 0. And when I plug in 3, I'm going to get 27. So obviously this one is increasing faster there. But hopefully you realize that the bigger the number, if it's exponential, the more it's going to increase. So anything bigger than 3, this one is certainly going to increase a lot quicker than this one will. And then the last one, hopefully, like I said, you use Desmos, and you should have got, or I'm sorry, not that one, sorry. Because you don't have to write you just had to write what kind it would model with. You should have found the differences. The first difference doesn't work. The second difference doesn't work. You're going to need the ratios. And when you do the ratios, you should have got that it works, and that would be exponential. Now, things to note. There is not one on here where you have to graph it. You will definitely have to do that. So I'll give you like a function. You're going to tell me, what are you going to tell me? The vertex, axis symmetry, if it's a max, if it's a min, does it open up or does it open down, right? You're going to tell me the y value at that max or min. You're going to tell me the domain and the range. You're going to tell me the y-intercept. All of those things are kind of what I'm looking for. And then you're going to just draw kind of a nice copy of what that graph would look like then. Note that I don't want you to make a table. I just want you to kind of use that information, plot the y-intercept, know if it's going up or down, and then kind of make a sloppy copy from there. Not sloppy, but you know what I'm saying. Yeah, that's going to be the main focus, is stuff like domain and range, and where's the vertex. You might have some of those vertical motion ones for sure. Those aren't on there, but you can look over those in your notes. And then obviously just being able to graph it. So yeah, all right, that's a pretty good picture at least of what's going on. If you guys have any questions, let me know. I can help you guys out and make sure you're ready for this thing. After this test, I think we only have 2 more in the 4th quarter, and then we're done. Yay! Almost there. All right, I hope you guys have a great spring break. Good luck on your test. Do good. Know what's going on. Let me know if you need any help. I will see you later.